I mentioned earlier, we have these pairwise preference ratings. We convert them into a Bradley-Terry score. And the main thing you'll probably notice is that the human raters really separate the human-human conversations from the human-AI ones. They do this very well. They very much prefer the human-human conversations, but our metric doesn't really separate them. And that's somehow expected because it wasn't really designed to do this. However, if you look at the human-AI conversations, you can see a slight correlation. It's a very low correlation, but it's a significant one. So that brings us to the takeaways and future work. We can distinguish high success and low success conversations using these very simple acoustic features. But it's very important, of course, to differentiate between human-human, human-AI, and AI-AI conversation. So Harsha will talk about that next.
All right, okay. So I'll first start off by just reminding everyone that Johan Skalkvik talked to us about the uncanny valley, and in my part, I suppose I'll show you how to cross it, which is, the trick is to use the distributional metrics. Yeah, so we're going to be working with human-human, human-AI, and AI conversations, and I want to ask two related questions. The first one is, what can we say about human-human conversations that we cannot say about the other two, and what can we say about the different types of human-human conversations themselves, right? So I'll be looking at it at the turn level, so which is how are the individual turns in these conversations different, and also at the conversation level, which is to do with the dynamics. Right, so to cross the uncanny valley, because there are many ways to have successful and unsuccessful conversations, we're going to look at some distributions of features that we think are interesting in these conversations. And I looked at speaking rates, pitch, syllable durations, turn duration, pause duration, speaker ID embeddings, emotion labels, and other SSL features. And they get less interpretable as we go down, but just to make everyone understand, I think I'll focus on turn durations, speaking rates, and pause durations, and we'll eventually find out that speaking rate is really good. So yeah, right now I have a bunch of violin plots. In green are the high success and low success human conversations, and in yellow are the human AI conversations and the human AI turns, and the red is the AI conversations. So what you can see is in high success conversations, there are shorter, more frequent turns, so it's quicker responses. And in low success, there are longer turns and slow responses. So if we go to something like response gap per conversation, the first interesting thing you'll notice is that humans change their own behavior when they're talking to AI versus other humans. And the AI response pauses are generally a bit larger. This is for both full duplex and cascaded. But on the red, you'll sometimes see that AI conversations, they just talk over each other. Sometimes they can have two simultaneous conversations. Next, we'll just look at speaking rate. So at the turn level, what you'll see is the AI turns are generally a little faster, but it doesn't have the same range as the humans. So that's in the human-AI conversations. So yeah, so I showed you guys all these distributions, but the question is we want a single number out of it. And we also want this single number to correlate with stuff like conversation success, whether it's task-oriented or not. And the sort of claim that I can make is if the distribution of AI turns becomes similar to human turns, then we have taken some steps into the valley. And so what we did is we took those distributions and then we computed the Frechet distance, which is just a measure of how much effort it takes to move one distribution into another. Yeah, so we found the Frechet distance and then I just rescaled it with some anchoring noise distributions. And basically our first goal of building metrics that can tell apart the distributions is met. So when we get a new conversation, we just find the score and then we put it back in this scale and then we can sort of tell where it comes from. This is the more interesting part. I think this is sort of a measure of how well it correlates with success or humanness and also generalization to another data set that we've never worked with. So what you'll see here is on the x-axis is the distributional score that's been rescaled So on 0, you have the medium success conversations, and on 100, you have the high success conversations. And then, so these are from Candor, right? And then we took the Voice Arena Goals data set, which is something about task-oriented dialogues. And what you'll see is the distribution of those turns when people are talking with AI, they're like almost exactly at halfway through. So they're distributionally neither medium success or high success, while the human conversations, they're sort of spread all over. So that's very cool, right? I think so. And then if we just look at, zoom in on that part, our distributional metrics can also rank the systems themselves. So with just 20 conversations, which are like 5 to 15 minutes, just by using our Candor data set, we can classify how well the system did. And we're just looking at speaking rate. And we were able to get something like 0.5 correlation. Whereas when we were looking at entrainment, the most we got there was 0.18. So yeah, so it seems to work really well, and we're gonna keep working on it. But the other interesting thread that I left out is, what about long-term behaviors? So humans can talk to each other about nothing for basically hours and hours. And you saw Candor is like 25 minutes, and the ones we worked with are 5 to 15 minutes. But yeah, the AI simulator conversations we were able to generate was up to 5 minutes. But if you try to generate more than 5 minutes with the current models, it's very funny. I'll just show you a quick snippet of how it sounds like.
You know, get it too far, you know what I'm saying? I wouldn't want to do that. I wouldn't want to, I wouldn't want to, I wouldn't want to take it to that. I would.
So basically you heard 3 snippets, something at 2 minutes, something at 4 minutes, and something at 8 minutes. But yeah, so I think it's really interesting to find out if realistic long context conversations between humans and AI is possible. It's not just a context management challenge like you do between AI and simulators. So it could be really interesting to build these long data sets. And currently, the simulator or these AI models, they can't sustain a conversation long enough to allow these interesting dynamics like entrainment to develop. So there are a lot more miles to go. Yeah, so that was about the objective metrics, and Patricia will talk about the objectives.
Thank you. Okay, being mindful of the time, I will probably have to speedrun this a little bit, so sorry if you don't understand something, but let's try to catch up on the timing. Okay, so quickly, we have 2 options. We can focus on judging the content only, using text.